Lesson 7.7, Exponential Functions. Let's first have a review of the rules of exponents. If you have an exponent of 0, any number raised to the power of 0 equals 1. Negative exponents, you take the reciprocal and make the exponent positive. Product of powers, add the exponent. Power of a power, multiply the exponents. Product to a power, distribute the power or the exponent. Quotient of powers, subtract the exponents. So let's do an example of each of these. Power of a power, we're going to multiply the exponents. So for example, if I have x to the 5th raised to the 3rd, I'm going to multiply the 3 and the 5 and get x to the 15th. Product to a power, I'm going to distribute the power. So for example, if I have 2x to the 3rd, y to the 7th, and I square that, I square the 2, I square the x to the 3rd, and I square the x to the 7th. So I end up with 4. 2 times 3 is 6, and 2 times 7 is 14. Quotient of powers, I need to subtract the exponents. Whoops, sorry about that. So for example, if I have x to the 5th over y to the 10th over x to the 3rd, y to the 17th, I subtract 5 minus 3 will give me x squared, and since the 5 was larger, the x squared is on top. 17 minus 10 will give me 7, and since the 17 was larger, the y is on the bottom. Exponent of 0, any number raised to the power of 0 equals 1. So I can have 50 billion, and if I raise that to the power of 0, it equals 1. Negative exponents, we take the reciprocal and make the exponent positive. So if I have 5 to the negative 2, that's 1 over 5 squared. If I have a negative exponent in the denominator, I bring it up top. And if I have both, I switch places and make the exponents positive. And a product of powers, I add the exponents. So for example, x to the 6th times x to the 10th, that gives me x to the 16th. So let's talk about exponential functions. Exponential functions are of the form y equals ab to the x. A cannot be 0. A cannot be 1. B is not 0, and x is a real number. So if we compare functions, a linear function gives us a straight line. A quadratic function gives us a parabola. And an exponential function gives us an increasing or decreasing curve. If I have an exponential function that is going up as we move from left to right, this is called exponential growth. If I have an exponential function that moves downward as I move from left to right, this is called exponential decay. And next, what we need to discuss is how to graph an exponential function. Okay, so graphing exponential functions. So as I said, they're of the form y is equal to ab to the x, where a is not 0, a is not 1, b is greater than 0, and x is an element of the real numbers. So for our first example, we're going to graph y is equal to 4 times 2 to the x. Now this will be a little different than what we're used to, but I use an XY table on these. To me, that's just the simplest way to go. And I'm going to make my coordinate plane. My x and y axis. Now I come over to the left because an exponential won't do a whole lot on the negative side necessarily. So I want to plug in a 0. And as we know, any number to the power of 0 is 0. So what I'll get is is 1, not 0. Y is equal to 4 times 2 to the 0, so that's 4 times 1, so that's 4. If I plug in 1 for x, I get y is equal to 4 times 2 to the 1, so that's 4 times 2, so that's 8. If I plug in 2, I get 4 times 2 squared, so that's 4 times 4, so that's 16. And as you can see, I'm growing rather rapidly. That's what happens with exponential functions. We grow really quickly. If I plug in 3, 2 to the third, 4 times 8, 32. Now I didn't make my graph quite tall enough for that, but I'm going to go ahead and show you what happens if we plug in a negative. So if I plug in negative 1, I get 4 times 2 to the negative 1, so that is 4 times 1 over 2 to the 1. 4 times 1/2 is 2. If I plug in negative 2, I get 4 times 1 over 2 squared, so that's 4 times 1/4, so that's 1. If I were to plug in negative 3, 4 times 1 over 2 to the third, so 4 times 1/8, so that's going to be 1/2. Okay, so graphing this, I'm going to plot these points. I have 0, 4, 1, 8. And as you can see, I didn't actually leave myself quite enough room. So what I'm going to do is I'm going to change my scale real quickly. Make this 2, 4, 6, 8, etc. So I'll have 0, 4, 1, 8, 2, 16, so 10, 12, 14, 16. And then I had negative 1, 2, negative 2, 1, negative 3, 1/2. Now, an interesting thing about exponential functions is they never actually meet or cross the x-axis. And here's why. Let's say I decide to plug in a really negative number, because as you can see I'm moving down further. Let's say I plug in negative 10. I would have y is equal to 4 times 2 to the negative 10th, so that would be 4 times 1 over 2 to the 10th. Now 2 to the 10th, hold on one second, is 1024. So 4 times 1 over 1024. So that would be 1 over 256. So let's plug in negative 100 and see what happens. I would get 4 times 1 over 2 to the 100. Well, 2 to the 100, that's a really big number. Maybe we won't go 100. Maybe we'll do 30, negative 30. So y is equal to 4 times 2 to the negative 30. So 4 times 1 over 2 to the 30th. And 2 to the 30th is 1073741,824. So that would give me the answer of y is equal to 1 over 268435456. But as you can see, I'm still not hitting 0. I will get infinitesimally close to 0, but I will never actually hit 0. So when you draw your exponential function, you come in along the x-axis, but don't touch it, and then you connect your dots like so. Okay, let's try another one. Let's try one with a fraction. Let's try 1 is equal to 2 times 1/2 to the x. So I'll make my xy table. And before I make my coordinate plane, I'm going to go ahead and calculate some points just so I can see what I'm going to be getting myself into. If I plug in 0 for x, I get 2 times 1/2 to the 0, so that's 2 times 1, so that's 2. If I plug in 1 for x, I'll get 2 times 1/2, so that's 1. If I plug in 2 for x, I'll get 2 times 1/2 squared, so 1/4, so that's 1/2. If I plug in 3 for x, I'll get 2 times 1 over 8, so that's 1/4. And as you can see, I'm getting smaller and smaller and smaller and smaller. I'm going to go ahead and do some negatives. I'll do -1, -2, and -3. So if I do -1, I get 2 times 1/2 to the -1, so that's 2 times 2, so I get 4. If I do -2, I'll get 2 times 2 squared, so that's 2 times 4, so 8. And if I do -3, I get 2 times 2 to the 3rd, so that's 2 times 8, which is 16. So let's go ahead and make our coordinate plane. This time I'm going to come a little bit lower. Maybe a little bit lower. And again, I don't need to go that far over. So 0 gave me 2, 1 gives me 1, 2 gives me 1/2, 3 gives me 1/4, -1 gave me 4, -2 gave me 8, and -3 gave me 16. So again, to draw this, I'm going to bring in my curve really close to the x-axis but not touch it, and then follow this up like that. Now you can bring this out farther if it looks prettier to you, however you'd like to do that. Just don't touch the x-axis. And that is how you graph an exponential function. So what we've learned is that if b is a whole number, we're going to go up. And if b is equal to a fraction, we're going to go down.